Welcome. This is your first remote lesson for geometry class. You can print out these lesson notes from the website and fill them out as we go through the video. Or if you can't print them out at home, you can just take a piece of binder paper and write all of the problems down. You'll need to write all of the actual questions as well as the work that's going to be shown in a little bit here onto your binder paper, though, because you need to make sure you also have your name and date. We will be doing a binder check when we return back to in-class instructions. So this first part of our lesson is kind of a review of distribution property that you learned in Algebra 1. And so we're distributing that 5 over the binomial x plus 3. And you end up with 5 times x plus 5 times 3, which then simplifies. You can pause the video at this point and to slow after any problem, and that'll give you time to write down the problems. Also, you might want to pause it so that you can move forward and do these problems and then check your work as you go. Okay? So the second problem, we're distributing that x over the binomial, and we end up with x times x minus x times 3, which simplifies to x squared minus 3x. This third one, we've got two binomials, x plus 4 and x plus 2. And we're going to distribute this first binomial, x plus 4, into the second binomial, which means we're going to multiply the x in the first one times both the x and then the 2. After we do that, we're going to take the 4 and we're going to multiply it times the x and then times the 2. And then we're going to collect like terms and simplify. Pause the video, try it, and see how you did. So we get x times x plus x times 2, and then we get 4 times x and 4 times 2, which simplifies. And we get x squared plus 6x plus 8. Now we're going to do the second one, or the second of the binomials that we're going to multiply together. This time it's x minus 5 times x minus 5, distributing the x and then distributing the negative 5 across the other binomial. And then we simplify everything, and some of the terms simplify before I want to collect them. I've got a negative 5x, and then we have another negative 5x, plus we're going to multiply the x's together, and we're going to multiply these two negative 5's together, and you end up with the following trinomial. You get x squared minus 10x plus 25. So we're going to be doing more of these, multiplying binomials like we just did a few minutes ago. But you'll notice every single time the two binomials are the same thing. So here we've got x minus 7 times x minus 7, which I could have written like I did the other three that are written here, could have been written as x minus 7 quantities squared. That makes these what they're known as is binomials squared, because we're multiplying a two-term statement. So that's called a binomial squared. Using a distribution property, just like we did in the previous problems, both distributing the x and then distributing the negative 7, we end up with an x squared. We end up with a 49, and we also end up with a negative 7x and another negative 7x. Now, down here you'll see what we did is these are binomial squares, and instead of, for a moment, I want you to look at all of these that we're going to use this terminology. There's the first term of the binomial, and, so I have plus, the last term of the binomial. So in this problem up here in part A, the first term is x, and the last term is negative 7. So in this binomial squared, we have the first plus the last. We're going to be using it with all the other ones, and what you end up getting is you get the first one squared, like we had right here, the first one squared. And we get the last one squared, and we also get twice, meaning 2, of the product. And with letters, I can write that here as the first one squared and the last one squared, and twice their product, like this. And this is called a perfect square trinomial. When we have the very first term is a perfect square, and the last term is a perfect square, and the middle term is twice the product of what we squared for the first and last, then we have a perfect square trinomial. So I'm going to take this first problem, I'm going to move this to the side, and we're going to do this problem this time. Instead of distribution, we're just going to follow the pattern that we have down here, this pattern. And so we have the first one, x, and the last one, which is -7. So we have the first one squared, and the last one squared, and twice their product. And so I wrote that as 2 times -7x, which simplifies to x squared minus 14x plus 49, which is exactly what we had when we used the distribution property here. So for the next 3 problems, we're going to use this pattern. Why don't you pause it, try to do these 3 problems, and then you can start the video again to check to make sure you did your work properly. So for part B, we have the first one squared and the last one squared, and twice the product of x times 4. And we simplify all that, and we get x squared plus 8x plus 16. Part C, my 2 terms are x and -10. So I have the first one squared and the last one squared, and twice the product of x and -10, meaning -10x. Simplifying it, and we have x squared minus 20x plus 100. The last one, we've got the terms x and 1. So the first term squared is x squared, the last term squared is 1. Twice their product gives us 2x. So we've got this perfect square trinomial. Each one of these is a perfect square trinomial. So now we want to identify, are they perfect square trinomials? In part A, we notice that it starts with a perfect square and ends with a perfect square. So we've got x that's being squared, and what is being squared to give us 9? Well, we've got a choice. It could be +3 or it could be -3. The symbol right in front of the middle term tells us which one it's going to be. Since this is negative, I know it's going to be -3, not +3. Because -6x is twice x times -3. So this does follow our pattern. That's what we're doing. We're just trying to find out which ones follow the pattern. In part B, well, we have a first term squared, but our last term is not a perfect square, so it does not follow the pattern. In part C, we have the first term and the last term that are perfect squares. We have a choice of 9 squared or -9 squared to give us 81, but right here it says +18x. So that tells us it will be +9, not -9. So it's not that it's going to be +9. Since 18x is twice x times 9. So yes, that follows the pattern. In part D, the first one is a perfect square, the last one is a perfect square. I know that it's going to be the negative if it works out, and yes indeed, -2x is twice x times -1. The third one here, the fourth one, part E, we've got x squared, which is a perfect squared. We have 16, which is a perfect squared, which is 4 squared. But this middle term is supposed to be twice their product. Their product is 4x. This is not twice the product. So no, it is not, because 4x is not twice x times 4. In this last part, we're going to write them as the binomial squares that they are. And we've already determined what it is we're going to multiply. Wherever we wrote where the twice, we say x and -3, that will be our binomial. So I know that 3a up above is x minus 3 quantity squared. And in part C, we have x times, up here we have x times 9. So I know that these are the first and the last, that I'm going to put in for the binomial. And we have part D, where we've got the x and the -1. So for 5.3, We need to review for just a moment what we did in our last lesson. In lesson 4, we used the Pythagorean theorem, also known as the distance formula, to come up with the equation of a circle, and we ended up at the very end of our lesson writing this down, and we discussed how this is the equation of a circle when the center of the circle is the point h comma k and the radius of the circle is r. Now remember that this is x minus the h, so this has to be written in this format where we're subtracting something from x and we're subtracting something from y, and those give us the center of the circle. In this problem right here, we are subtracting from x, and that's a 2, but it doesn't look like we're subtracting from the y. But remember that if you subtract a negative, that's the same thing as addition. So what we are subtracting is -7. So we're subtracting a 2, and we're subtracting a -7, which means our center is 2, -7. The radius is saying, what are we squaring? Well, we're squaring 10 at the end of the equation. So what are we equaling? We're going to, for this next part, for part B of this problem, we're going to multiply out. We're going to use that multiplying out a binomial squared, and that will help us to figure out how we could rewrite this equation in what is called general form. When we write it this way, when it's the format that we had up here from the distance formula or for the Pythagorean theorem, this is called the standard form of a circle. But if we write it out, expand out each of those binomial squares, where we have the first one squared and the last one squared, and twice their product, and we also have the group y plus 7, so the first one squared and the last one squared, and twice their product, and that's going to equal 10 squared, which is 100. We need to collect the like terms of 4 and 49, and we're going to also, besides collecting those like terms, we're going to arrange this so that we have our squared terms first, x and then y. Then we have our first degrees, our -4x and our positive 14y. Then we collected 4 and 49 and wrote 53. And lastly, what we're going to do is we're going to subtract this 100 from both sides of the equation. So we'll have -100 equals 0. Our very last step is to collect these two terms together, the 53 and the -100. And we have our general form of a circle. Okay, so that's what this is, a general form of a circle. In problem number 2, we're looking at this and saying, can this be written in standard form? So to remind you, here's the equation of a circle. We have two binomials that are being squared. And we look at the first three terms, this trinomial, and we say, oh, wait, that is a perfect square trinomial, because the first term is being squared and is a perfect square, and the last term is a perfect square, and the middle term is twice the product of their square roots. And we see that same thing occurs with the next trinomial, that it is a perfect square trinomial. So we can write the x's in x plus 3 quantity squared. We can write the y's as y minus 5 quantity squared. And lastly, we're looking at that 64 and saying, what is being squared to give us 64? And that is 8. So now we have almost this format, but this x plus 3, it needs to say x minus. So I'm going to change the x plus 3 to x minus -3. And we have the y already minus, so I'm going to write that it's y minus 5. And so this is telling me that I wrote in red, -3 and positive 5 is my center. And my radius is what we were squaring over on the right, which was 8, because we had 64, so that was 8 that was being squared, which is the radius. This last problem here is taking all of what we've been discussing with circles and turning it into a sphere, which is graphing in a 3D plane. So we've got not just the x and y axes, but we have one more. We have the z axes. And it's still based on a distance formula, so we're still going to be using binomial squared, But this time, instead of using HK as our center, we have A, B, and C as our center. So we would be taking this, which is the x for the center, and we're going to have x minus that A. And that x minus A, quantity squared, is the first part of the equation. Then we have the y minus b being squared. And then we have the z minus c that's squared. And it's going to equal our r squared. And that is the equation, the standard equation for a sphere in a 3D, meaning x, y, z plane. This is the end of our first of our remote lessons. I know it's a little bit longer, it's 15 minutes. Hopefully they'll be a little bit shorter as the week goes by, but make sure you have those notes, put them in your notebook, and then go to the website to look up your homework. There will be a video quiz, also a 3-question quiz posted.